Hello, everyone. Welcome to our exciting live introduction to algorithmic challenges in Kotlin. I'm Ksenia Schneeves, a Kotlin education advocate at JetBrains. Today's live stream will not only provide you an overview of the algorithmic challenges in Kotlin course that we've recently released, but it will also feature two brilliant minds in the field of algorithms and data structures, our wonderful speakers, who will share their practical tips and demos on solving popular algorithmic challenges often encountered in technical interviews. So we hope that this live stream will level up your understanding of algorithms and prepare for your next technical interview. So let's give a warm welcome to our guests, Alexander Kulikov and Pavel Mavrin, who are also co-authors of the Algorithmic Challenges in Kotlin course. Alexander is the head of the Laboratory of Algorithms and Complexity Theory at JetBrains Research and a co-author of the book, Ace Your Next Coding Interview by Learning Algorithms. Pavel is an experienced tutor and researcher at JetBrains, an expert in algorithms and data structures, and competitive programming champion. In 2004, Pavel won a prestigious ICPC World Championship. And before I hand the floor over to Alexander and Pavel, I have a few more words about the live stream. It is being recorded, so you can watch it at your convenience and share it with your friends and colleagues. The live stream is a part of our educational videos, and you can find this Kotlin for Education playlist on this YouTube channel. Don't hesitate to check it out later. And in the description to this live stream, you can find the course Algorithmic Challenges in Kotlin that we'll be referring to, along with the links to two problems our speakers will cover today. Feel free to open the problems to solve them along. And since we're all here in this live stream, we encourage you to take this opportunity and ask your questions in the chat, share your experiences, and leave comments. Please feel free to ask us anything. We'll have a Q&A session at the end of the live stream, and we'll be collecting your questions. I'll be collecting your questions as we go, so don't hesitate to engage with us. To kick off our interaction, let us know where you're joining us from and whether you have any prior experience with solving algorithmic challenges. All right, now let's get to the main part. Please give a warm welcome to Alexander and Pavel.
Yeah, hi everybody. Ksenia, thanks a lot for the nice introduction. So let me tell you a few words about our new course. Once again, so let me repeat what Ksenia just said, that in the description to this video, there are two links to interactive puzzles where you can play with two algorithmic problems, and they're mobile friendly, so you do not need to implement any code. So they just push you to invent some algorithmic idea, and I will cover solutions to these puzzles in a minute. Okay, so let me start by introducing the authors of this course. So there are three of us, me, Alexander Kulikov, Pavel Mavrin, and Yasmin Matulin. So we have something in common. So we are the authors of this course. We love algorithms. We work for JetBrains. There are also differences. So for example, Pavel and Yas are ICPC champions, and I am not. Okay, so the contents of this short presentation is the following. So we will first explain why you might be interested in this course. So we will tell about algorithms, about Kotlin programming language, and about IntelliJ IDEA. Then we will show you how the course looks like in IDE. So we will show you the pipeline of solving these problems. Then we will cover solutions to two algorithmic problems. And by this, I mean algorithmic ideas needed to solve these two problems. Then I will pass the floor to Pavel, who is going to show you in a live fashion how to implement algorithms for these two problems right in the IntelliJ IDEA. And finally, we will answer all questions that you might have. Okay, so let's go. Let me start by providing some motivation for studying algorithms. So this is probably clear if you are here already, but still. So the first one is probably just out of curiosity. So there are many interesting and elegant ideas in algorithms, and that's why probably many people are interested in competitive programming. Also, by learning algorithms, you actually learn in practice actually to implement efficient and reliable solutions. So if you participate in competitive programming competitions, you probably know that you need to implement a solution that passes many carefully designed tests and do so under a given time limit. So basically what you need to do is to implement an efficient solution and a reliable solution. Also, when you learn algorithms, you also learn many data structures, which allows you to select the right data structure when you face a new computational problem. Also, when you know algorithms and when you know how to estimate the running time, you actually are able to predict the running time of your program, which actually implements some algorithm on for example, massive data sets. So in competitive programming, if you participate in such competitions, you know that if your program works well on small data sets, it does not mean that it works well on large data sets. So you always need to test your code on massive data sets. And finally, the final reason is more pragmatic, probably. So the first four reasons actually imply that, I mean, this is what IT company usually would like you to know. And this is the reason why interviews at top IT companies actually contain the algorithmic sessions. Okay, so in our course, you are going to implement these algorithmic challenges in Kotlin. So let me just say a few words why Kotlin is a good choice for this. So first of all, Kotlin is a compact programming language, so you don't need to spend time on typing. Also, there is a rich standard library in Kotlin. Also, it is easy to test your code in Kotlin, as Pavel will show you today. And also, so it generates efficient code. So it is known to be fast. Okay, so why you would like to implement these challenges in IDE? Well, the first reason is that many professional programmers actually work in IDE. So this just makes you more efficient. So by doing this, you code like a professional, right? Also, in IntelliJ IDEA, there are many smart features, and we will focus on some of them at today's talk. And finally, so some of these features are actually debugging features. So it is convenient to debug your code right in the IDE. Now let me show you how it looks like. So this is a screenshot of our course. So and the assumed pipeline is the following. So you first browse the course structure. So you see it here on the left. Okay, then you read the problem statement, which can be found in the right pane. Okay, then you can start implementing your code just in the middle here in task KT file. Right, the next step is to use code inspection. So the idea actually helps you by providing you some suggestions about your code. Then you implement some tests just to test your code. And then when you are ready with this, you can debug your code if needed. And when you are happy with your implementation, you can actually press the check button, which runs your implementation against dozens of carefully selected tests. And finally, you can also you can also check check the reference solution, and first you can see how we implemented a solution for this problem, and you can also compare your solution to this problem. Okay, now let me jump to the first algorithmic problems that we would like to cover in this short talk. So in this case, this problem is called opposite values, and this is kind of a puzzle. So in this case, we are given a sequence of 20 bits, but we only know the leftmost bit and the rightmost bit. So we know that the leftmost one is 0, whereas the rightmost one is 1. Okay, so our goal is to find a 0-1 pair. That is an element in the sequence which is 0, which is immediately followed by 1. Okay, so one strategy for doing this is just to, for example, to start accessing the elements from left to right. However, in this case, in the worst case, you will need to reveal just all the elements in your sequence, right? And what we would like you to think about is whether it is possible to find such a pair by revealing just a few elements in this sequence. And it turns out that this is possible, and this can be done by the divide and conquer strategy. Okay, so to show you how it can be done, let's just reveal the middle element of our sequence. Okay, so assume for simplicity that this element is equal to 1. Okay, and then what is important in this case is that from now on, we can focus on the left half of our sequence, just because, once again, for the left half of our sequence, we have the following property. The leftmost element, of this half is equal to 0. The rightmost element of this sequence, of this half, is equal to 1, which basically means that somewhere in the middle there must exist a 0-1 pair. Okay, so taking this into account, let's just focus on the left half. So let me just zoom in to the left half, and let me check the middle element of this left half. Okay, so this is the left half of my sequence, and assume that its middle element that has just been revealed is equal to 0. Once again, this allows us to tell that in the right half of this half, there must be a 0-1 pair, which allows us to focus on this right part. So let's just do this. Once again, we reveal the middle element, we see 0, so we focus on the right half again. So let me do this. Okay, so again, we reveal the middle element, it is 0, we focus on the right part. Finally, we reveal the middle element here, and this allows us to find, finally, the 0-1 pair. Okay? Now, let's zoom out back, and in general, we know that in this particular case, we have 20 elements, and by revealing just 5 elements, we're able to find the 0-1 pair. In general, if we have a sequence of n bits, it is not difficult to see that it will require us to reveal at most log n bits, right? Just because at each iteration, we essentially reduce the size of the sequence by 2. Okay, so this is a very popular algorithmic strategy called divide and conquer. In this particular case, it allows us to find the answer in just log n steps, big O of log n steps. Okay, for the second problem. So it is called collecting signatures, and the legend in this case is the following. So assume that we have a building with 12 tenants. So as the problem title suggests, we need to collect signatures from all these tenants and assume that for each tenant we know the period of time when he or she is at home. Okay, so our goal now is to collect the signatures of everybody, but at the same time we would like to minimize the number of times we visit the building. Okay, so this is how we can model this problem mathematically. So first, let's just plot all the time periods on as follows. So we draw vertical lines corresponding to to periods of time, and then the time slot when each tenant is at home corresponds to a segment, right? Then we can construct a solution for this. Oops, I'm sorry. We can construct a solution for this problem using, for example, 6 periods of time, right? So we can visit the building at 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., and 6 p.m., and this will give us a solution, right? It is not difficult to see that each of the 12 tenants is at home at either 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., or 6 p.m. So now the question is whether it is possible to reduce the number of visits to this building, right? So the question is, can we do this by visiting the building 5 times instead of 6, or probably even 4 times? And more generally, of course, we're interested in whether it is possible, how it is possible to solve this problem in general. So given n segments on a line, how you can touch all of them with the minimum number of points. Okay, and to solve these mathematically clean, let's do the following. So let's remove all unnecessary details. So at this point, it is not that important that these segments represent periods of times. So these are just segments on a line, and we would like to touch them with the minimum number of points. Okay. Now let's do the following. Let's just consider the smallest right end point of all the segments. So it is now highlighted in yellow on my slide. Okay. Now a simple but crucial observation is the following: there exists an optimal solution, that is a set of points that touches all segments and has minimal possible size that contains this yellow point. And this is why. So we need to touch the segment whose yellow endpoint is shown here. And actually, if it is covered, if it is touched not by this particular point, then we can actually move it to the right, right? So let me just show you how it happens. So if this segment is covered by a vertical line or by a point which is not the right endpoint, then we can just move this point to the right, and by doing this, we will not lose any touched segment, right? So this should be proven actually mathematically, but intuitively it is clear that it is true, and we leave it to you as an exercise to prove it formally. And the nice thing about this is that since we know that such a point belongs to some optimal solution, we can actually remove all the touched segments and just continue with all our white segments, right? So we, in this case, we can do the following. We just select the next smallest right-hand point, and the next one, then once again the next one, and finally the last one. And this basically constructs us a solution with five points, and in general this leads a solution which works in time n squared. If we do this naively, I mean, if at every iteration we just select the minimum right endpoint, and then we scan all the segments to check which ones are covered by this particular point. At the same time, we can also, before doing this, we can also sort all our segments by their right endpoints. This can be done in time and log n. And by doing this, we actually can then find a solution just by a simple scan from left to right of all the segments. So in general, the strategy that we're applying here is known as a greedy strategy, just because, and it is called so just because we know that for the segment with the smallest right endpoint, there must be a solution that contains this right endpoint. So we just include it into our solution, and then we continue. And there are many problems that can be solved by greedy in a greedy fashion. At the same time, there are much more problems that cannot be solved by greedy algorithms. And the one more large algorithmic paradigm that is covered in our course is called dynamic programming, and it is probably wider applicable than greedy algorithms, and you may find it in our course also. So this is basically all that I wanted to say about these two problems. So let me now pass the floor to Pavel, who is going to show you how to actually implement solutions to this problem in Kotlin, right in the IntelliJ IDEA, and how to submit this to the grading system. Okay, so now let me stop sharing. Okay. Yeah, Pavel, the floor is all yours. Yeah.
Okay. So hello everyone again. So this is how the course looks in IntelliJ IDEA, like Alexander already showed you. So we have 3 sections. In the left, we have the course structure. You can choose what problem to solve. In the right, so when you choose the problem, like here, I choose the opposite value of problem, like the same problem we discussed right before. So in the right, you will see the statement of this problem. So this brief description and some number of small examples so you can check. In the middle, you have your code, and when you need to implement your solution. So what we have in this problem is, again, like, let me remind you what the problem is. You have a sequence of characters like string, and you know that the first character is 0, last character is 1. You need to find a sequence of 0 and 1 somewhere in the middle of the string. What we have in this problem is, as a starting point, we give you already some solution for this problem. So we give you this very simple solution. We just call standard function index of, which actually used to find some substring in this char sequence. So we just run this function, and it will give you what you want. It will give you the position of substring 0, 1 in this string. And if you run, so this is perfectly normal solution, actually. So you can run this solution on this test. So you can go in test section. And here, let me hide this. Here we have some number of small tests. Basically, these are the same tests we use here. So you have these tests here. We just implemented them here. And if you run these tests, let me run these tests. Okay, so if you run this test, you say build successful. So all these tests pass correctly. So this solution is actually works correctly on these tests. You can add your own tests here. You can, again, like a normal. It's just your normal unit test. Again, the problem is in this solution is that it's slow solution. So this function index of uses linear time solution to just scan this string from left to right and find the first occurrence of this substring. And if you try to submit this solution here, if you press this check button, your solution is tested on some number of hidden tests. And some of these tests are huge tests. For example, like in this test, we have 500,000 queries on some long string. And if you just use this solution, it will be just too slow. So it exceeds the time limit for 6. So we set some time limits for these solutions. Again, if you take part in some programming competitions, it's basically like you have time limit exceeded error in your solution. It's maybe not that accurate as in programming competitions, because in programming competitions they run in some specified sandbox. So all the solutions are run on the same environment. Here we run it on your computer, so it may be different. But for For these solutions, it actually doesn't matter. So the difference between efficient and inefficient solution is too big. So let's try to implement efficient solution. So again, let's do the same thing we did, like Alexander explained. So we will maintain two borders of our current segment. We'll say left border will be set to 0, and right border will be set to the last character of the string. It just length -1. And we maintain the invariant that left character is always 0, and right character is always 1. And now we'll move these 2 pointers closer to each other, each time trying to maintain this invariant. So what we do, we'll say while they're not neighboring characters, so while r is greater than l+1, I will try to move them. So how I move them? I take the middle value, let's say l+1 plus r divided by 2. Yeah. So I take the middle character and check if this character is 0, then I can move the left pointer to this position. And if it's not, I can move the right position. Now, every time I move one of the pointers to the middle position, maintaining the same invariant. So when this while loop is over, I know that I found two neighboring positions. Left position is 0, right position is 1. So I just return what I need to return. I need to return the left position. Yeah. Yeah. So again, this is your solution implemented in Kotlin. And using the check. Oh, and you say it correct. So your solution passed all the hidden tests. Your solution is correct. So this is how you solve these problems in the IDE. Let's move to the second problem. Second problem is the section of greedy algorithms. So it's collecting signatures. Here's one. And again, like before, so in the right you have task description. You have some number of examples here. For this problem, we don't give you some slow solution because it's actually pretty hard to get even slow solution for this problem. So we just leave you the empty placeholder here. What's interesting in this problem, we use some Kotlin features. For example, here we use data class. Data class is some nice feature of Kotlin programming language. So basically, it's a class specifically designed to contain some data. So you just write it like this. And again, if you program in Java, for example, what you do when you want to create data class, you create a class. You need to implement constructor for this class, maybe some getters for all this. For each field, you want to have a getter, yes, and you want to have hash code function, equals function, and so on. And basically, Kotlin just generates all this for you. What I'm doing here, so what I'm doing to solve this problem. So what I will do, I will iterate over my segments in increasing order by the right border of the segments. And the way I do it in Kotlin is very simple. I just say I want to iterate over all segments sorted by the right border of the segments. Just say by it. So that's all. That's how you iterate over all segments in specific order. So again, you can do it in any programming language, but just in Kotlin, it looks much more nice. So it just you don't need to write a lot of code just to do what you need to do. Now I iterate over all segments by the right border, and I just check if I need to add this right border to my answer. So let's say I have some answer. Result will be, let's say I need to return a list. Let's say a list of integers. Yeah. Now, when I need to add this border to my result, I need to check if this segment is already covered or not. So if it's not covered, how to check if it's not covered? If it's not covered, if my result is empty, or if my last point from my result is not covered in this segment. So I check the last point from my result. If it is covering my segment, so if this last point is greater or equal, so it's not covering. So I check if it's not covering if last point is to the left from the left segment, from the left border of my segment. Yeah. So this condition is true when my last point from my answer is not covering the segment I want to cover. So if it is not covering, I need to add the right border of my segment to the result. So we just result under the segment R. That's all. That's how you basically return. Well, basically the whole solution. Again, if you look how it's looked at Kotlin, it's much nicer than this other programming language. So the solution is very short. It's easy to understand. There is not so many noise from programming codes. Again, you can send it to section. Yes, and it's now you see the solution is correct. Okay, that's all. That's how you solve this problem in IDE. Okay, we can move to Q&A session, I believe now.
Thank you so much, Pavel and Alexander, for this great demo. I've been collecting questions and we've got a couple. So others from our viewers, you're very welcome to ask your questions now while we're in the Q&A session. And I'll start with the ones we've already got. There was a question about the Tower of Hanoi algorithm. Probably folks want to see how you suggest solving it.
I must admit that I don't remember. So if I remember correctly, we did not cover the Towers of Hanoi problem in our course. At the same time, this is a classical algorithm, of course, and there is a lot in the books and in the internet about it. So this is indeed a nice. So we do have a puzzle on Towers of Hanoi where you can play around with this, and you can just solve it on your mobile phone or in your browser. And this is indeed a nice first application of the divide and conquer strategy, but we do not cover this in our course.
Okay, thank you. Another algorithm that our viewers are willing to see you talk us through is tortoise and hare algorithm. And they're asking if it's still relevant for the interviews.
So could you tell again which algorithm? Tortoise?
Tortoise and hare. Maybe turtle and hare. We should maybe look it up.
I'm just not sure that I know this algorithm. So Pavel, do you know this?
Well, I'm also not familiar with this problem. So there are a lot of stories about tortoise and hare, but I'm not sure I know any algorithmic problem about this. So there are some math problems about tortoise and hare, but I believe I didn't see any algorithmic problem about this. Okay, if you can specify what problem exactly you're looking for.
I see a hint that it might be turtle and rabbit. No.
Oh, I see.
Does this ring any bell?
I see. So turtle and rabbit is probably this trick when you need to check whether a given cycle is has a loop or it is probably infinite. So yeah, this is a nice algorithmic trick, but it is just not very clear how you can like test it through a testing system. So this is a nice trick. Once again, you can definitely read it somewhere in the internet about the turtle and rabbit. It is probably not very practical trick. So it is very nice, it is elegant, but probably not very practical. And probably this is the reason why we're not covering this algorithm. But in any case, we just have no possibility to cover all algorithmic ideas in our course. So we selected just some representative problems that highlight probably the most important applications of most important algorithmic ideas. So something like divide and conquer, dynamic programming, and greedy algorithms.
I see, thank you. Another question looks a bit complicated to me, but maybe you can figure out whether we are able to answer it at all, or it's some kind of a puzzle. So the question sounds like this: what are the different Kotlin APIs that can be run as CLI for Google Cloud Platform Kubernetes engine by connecting one atomic Docker package method from IntelliJ IDEA for AI? So is that even a question?
Yeah, probably this is a question, but I'm not an expert. I think it's not about algorithms. So
Yeah, so unfortunately, we'll skip this one. Now, there was a question about why there is no heap in Kotlin, but I've already got some help from Pavel, who helped us to respond that there is Java until priority queue, which is available from Kotlin JVM as all other Java collections. So it can also be used as heap. Do you have any other comments to add to the question?
Yes, Pavel is perfectly right. Yes, so we can use all the Java library. Like one of the benefits of using Kotlin is that Kotlin is perfectly compatible with Java. So you can anything you can have in Java standard library you can use from Kotlin. Yeah.
Now let's see what other questions we got. Does the platform provide theory? So I guess that's about the course and the plugin course.
Oh yeah. So first of all, so we haven't mentioned this, unfortunately. So we should have. There are indeed theory steps in our course. So for example, we do explain how to use big O notation. This is not about implementing stuff, but this is about estimating the running time of programs and comparing different running times. So there is a theory step on this, and also in every chapter before we go to programming challenges, we provide several theory steps. So yes, there is theory, and also for every problem we provide a solution which consists of like theoretic solution and also implementation in Kotlin. So there is a lot of theory. So on one hand, you will be reading our theoretical explanations. On the other hand, you will be practicing applying these ideas by implementing these ideas in Kotlin.
Great, thank you. Another question was about how to install the plugin on IDE, and here I believe we have the instructions at the bottom of the course description, so you can just scroll down and there are the steps and the necessary links available on how to install the plugin on IDE. The question, another one, is about whether this is available for both community and ultimate versions of IntelliJ IDEA.
Oh, this is a tough
believe
one.
it is. It's not a question for me. Do I have Ultimate Edition? I don't think I have an Ultimate Edition of IntelliJ IDEA. I believe all the educational content is available for Community Edition IntelliJ IDEA.
Yeah, I think since the plugin itself is free, it works with the Community Edition. Another question is about fast pointer, slow points. I'm not sure if
this is actually the same as this is the same as turtle and rabbit. Actually, this is just another name for.
Okay.
Yeah.
So there were some comments about how this problem is called. Now, how is your approach of solving and practicing DSA algorithms within IntelliJ IDEA different from LeetCode?
So I don't know exactly because I haven't tried LeetCode. I only heard about the platform. So my guess is that there is some window where you can implement your solution, probably with code highlighting at LeetCode. In IntelliJ IDEA, you can use various smart features of IDE, of IntelliJ IDEA in particular. You can debug your code, you can use code inspections, so suggestions from IDEA, you can run tests and so on. So I'm not completely sure, but my guess is that this is missing at LeetCode. At the same time, at LeetCode, as far as I know, there are more problems. So there are hundreds of algorithmic problems. In our case, there are just around 30 problems, but we carefully selected them so that they are representative algorithmic problems.
Yeah, and Kotlin recently got support of the latest version on LeetCode, which was a very long-awaited event for us. Yeah. Another question is about how do you split a string into 13 or less lettered words joined by, but no word should be split up in 2 consecutive items.
I can understand. Can I see this comment? Sorry. I can understand it by hearing.
Yeah, just a second. I'll send it in the chat.
Split into 30. What? So if you want me to solve some specific problem, or what?
Yeah, probably. Yeah, the meaning of this question is for you to come up with a quick and elegant solution.
The viewers just testing us now. Okay, if we are capable to solve algorithmic problems. Okay, so how do you split a string into 30 or less lettered words joined by minus, but no word should split up into consecutive items?
I would not actually classify this as an algorithmic problem.
It doesn't look like an algorithmic problem. Yeah. It looks more like technical problem so you just take the string and split it into, okay, if it's just some problem you have in your interview, so maybe it's not an algorithmic problem, it's just problem that shows how you are capable in your programming language. So if you're capable enough to solve, just to do what's need to be done in your programming language, it doesn't look like an algorithmic problem. Yeah.
Okay, fair enough. Now there was a comment about the collecting signatures problem. When taken the n time, the number of visits is 5, but can be reduced to 3 by choosing some other time. I don't know if you have any comment on that.
I believe we just proved that it's impossible. So again, every time, like Alexander explained, in this problem, every time we pick some point, we actually prove that we should take this point, because again, if we take the segment with the leftmost right border, we need to cover this segment with at least one point, and we move it to the most optimal position. So we just can prove that it's impossible to do it in the less number of points.
Right. So yeah, on the one hand, we haven't done this formally, but it can be done, that our algorithm constructs an optimal solution. In our toy example, actually, it is probably not possible to cover it by 3 points. You can, if I remember our toy example correctly, there are just 5 segments that do not have any overlaps. So you definitely need 5 points to cover them. So probably if you feel that it can be covered by 3 points, probably try to rewatch this part. And I can actually, I think I can send the link to the slides in the chat so that you can go back to the corresponding example.
Yeah, we can add the link to the slides in the description so that it stays there with the video. Thank you. Another question is about the fun interface in Kotlin and where the viewers can use it in practical projects.
I didn't get it. So what interface?
Maybe it was, I think the question came during your demo, Pavel. Maybe you showed some fun interface in Kotlin at that moment.
What is fun interface? No, fun in Kotlin is just a function. So you have a functions and yeah, you can use this fun interface in Kotlin.
All right, more questions coming. Are there plans for doing this exercises or course in Java?
the fair answer is that I just don't know, actually.
Do you mean the same course, just the same problems in Java, or what?
Well, I think we can just
I believe that this course is
ourselves.
I believe this course is not like more about Kotlin, but about algorithms. We just choose Kotlin because Kotlin is like the good language to implement algorithms. So just to explain you how to implement algorithms in to have very compact and clear code. And if we have the same course in Java, we will just have much more complicated code, and it doesn't make sense to explain algorithms using just something like Java did.
Yeah. Another question building up on this one is whether Kotlin will completely replace Java. What's your opinion on that?
I'm not a Kotlin expert, so I believe Kotlin is much more future-proof than Java. So Java has a lot of again, Java was created much earlier than Kotlin, so it has some compatibility issues that we just can't. So it's just much older language, so it has some problems of old languages. So I believe Kotlin is much more future-proof in this case. So I'm not sure if it will completely replace Java, but again, it will grow much faster than Java. Yeah.
Thank you. Another question that's probably not going to be answered in detail is about how to start Kotlin multi-platform development. So my advice is going on kotlinlang.org and checking out the documentation, and our multi-platform team is working on more tutorials and more content. And on this YouTube channel, you will see a lot of videos and demos on Kotlin multi-platform. Anything else you have to add, Alexander or Pavel?
No, I don't know much about Kotlin multi-platform. I know some developers of Kotlin multi-platform, and I know it's great, but I'm not familiar with that technology. Yeah.
Mm-hmm. Another question is about the plugin and whether it works in Android Studio, which I don't think is compatible with the plugin.
No, I don't know.
I also guess so. I've never tried, and I just don't know, but my wild guess is that it is not compatible, right?
And an interesting question from Oliver is whether JetBrains uses these algorithms for interviewing candidates.
I just don't know. I mean, so different teams use different questions at the interviews. I do know about some teams using some problems, but it is not clear to me whether this is something that we can discuss publicly or not. So definitely many algorithmic problems are used, but probably we're not in position here to reveal them.
I think that every specific team for a product, they decide for themselves which types of algorithms and challenges to give to the candidates. So I'm not sure exactly the same algorithms or problems are used. I don't think so, but yeah, something similar is very likely. Right. Another question about Kotlin multi-platform and its future for cross-platform mobile app development. Do you have any comments on that?
Again, no. as I heard about Kotlin multi-platform, it looks very promising. That's all I can tell about it. I never tried to use it, so I don't have that. I'm not an expert in this program.
We do believe we in the Kotlin team at JetBrains, we do believe that a great future is there for Kotlin multi-platform, and we're doing a lot to promote it. and to get it stable, and it's already being used in production. For students and recent graduates, we are now running a Kotlin multi-platform contest. Top 3 winners who create the most interesting cross-platform apps will get trips to Kotlin Conf, the largest Kotlin event of the year. So feel free to check out the kotlinconf.com website, and there is a contest tab. So if you are a student or a recent graduate, feel free to check it out and take part in the contest. The prizes are really great. That was a short ad, a pause. And now let's see what other questions we had. Will there be updates to the questions in the plugin?
I believe there will be. So we now introduced the first version of this course, and I believe if we later want to fix something, so again, it's like the first version, and probably we will change slightly some problems, maybe add some more problems in the future. But I believe it will not change that dramatically. So the core of the course will stay the same. Yeah.
Is it possible to compare the solution that we write with other people, like lead code, in the plugin?
I believe right now we don't have this option to compare with other solutions. I believe it's not. You can see the author solution, like our solution. I believe you can't see other people's solution. And I'm not sure if we can publish this solution. I don't know.
Yeah, I think there is no such option right now. Right.
Okay, thank you. Now, another question about the course. Now you have 28 problems, so will you add more by yourself, or there's also a community opportunity to add challenges?
Nice question. Yeah, we for this first version of the course, we came up with all these problems ourselves. Probably for some future editions or for some like similar courses that we might develop in the future, it would be interesting indeed to collect problems from the community.
Is there a way community can send you the challenges they'd like to see in the course?
We actually there must be a Discord server attached to this course, so probably we will just try to announce something on Discord related to this. So this is, as far as I understand, this is the default place to discuss stuff about this course right now. In any case, so it is not that difficult, I think, to find Pavel's and my email. So we would be happy to hear your feedback and your suggestions. And if you are willing to participate in developing future editions, please just reach us.
Yeah, and you can also leave your comments underneath this video, this live stream, so that we are able to collect them here, or or check out the Discord if it's attached to the description of the course. So more questions. We have a pretty great and a very active audience today. We have questions coming up now about that fun interface. There is a suggestion that maybe the fun interface question was about single abstract method interfaces. Yeah, and the answer that this can be read about in Kotlin docs. Now, how to start learning algorithms, and any suggestions for books on this topic?
I'm not sure about what is the first book for algorithms. I know I always recommend Corman book, but I'm not sure if it's good as a first algorithmic book? Do you know any good book to start algorithms?
Yeah, my favorite one is a book by Dasgupta, Papadimitriou, and Vazirani. It is called Algorithms. Okay, and probably I also have a book on algorithms, which is located on Cognitera. So this is an interactive book. So it is also a beginner's level book. So if you are interested, you can definitely Google it. So we published it with Pavel Persner.
Yeah, and we have, I think in a moment I'll be able to have this link over in the chat. Just a second. And we're almost through with all the, now let's see if that's, no, sorry, that's the wrong link. Yeah, I'll just send the link to the book later. I'll add it to the comment section underneath this video. There is a comment that we can announce that the plugin is actually compatible with Android Studio. I didn't know that. And there was a question about JetBrains licensing the IDEs to users in Russia. No, we do not license the IDEs to users in Russia anymore. And I think with that, we've covered all of the questions. So if anyone has anything, any last minute questions they want to ask us, please feel free to do so now. Otherwise, we are wrapping up. Thank you, Pavel and Alexander. It was a great session. Thanks for the demos and the Q&A. You've covered many more topics than just the algorithms. Yeah, we don't have any more questions, so that's a wrap then. Thanks, everyone.
Yeah, thank you, Ksenia.
Thank you.